Hey everybody, today we're going to go over integrating products of powers of sine and cosine. So there are a couple rules when solving these problems, and we're just going to state those right now in the beginning. We have rule number 1. If you have an odd power on your cosine, you are going to pull out a cosine. Rule 2. Same thing with sine. If you have an odd power on your sine, go ahead and pull out a sine. Rule number 3, if your powers are even on both, you are going to have to use the half angle identities. Half angle identities. All right. So that being said, let's just jump right into our first problem and see what this actually looks like in practice. Example number 1. We want to integrate sine squared x cosine cubed x dx. All right, so the first thing I'm looking at here is my powers. So I have a 3 and I have a 2. This is going to fall under rule number 1. We do have an odd power on cosine, so let's just go ahead and pull out a cosine. So we're just going to split it here. We have sine squared x. I have a cosine squared x, and I'm going to pull out one cosine x. Don't forget your dx. You are allowed to do this at any point in time during any of these problems. You can just split your sines and cosines depending what you have. Following these 3 simple rules will make these problems go by a lot faster. All right, so from here, what I'm going to do is I'm going to go ahead and simplify this section. So now we have the integral of sine squared x. Cosine squared x is the same thing as 1 minus sine squared x. So that's using an identity right there. What we're left with is cosx and dx. So this portion was the same and this portion was the same, but all I did was use an identity right here. All right. From here, I'm going to go ahead and do a u substitution, and I'm going to do it on sine x. And sometimes you will pick the wrong u. Don't give up on it. Just try the other one. So if I were to pick cosine here, I wouldn't quite get a perfect u substitution to be able to do this. So go ahead and flop it to the other one and try that out before you completely give up on it. So the derivative of sine x gives me cosine x dx. Whenever I'm doing a u substitution, I'm checking to make sure I do obviously have my original u, which I do have sine in this case in 2 spots, as well as a cosine dx, which I do have in this case right there. So rewriting this with our u substitution, we are given u squared times 1 minus u squared again. Cosine is out because he was du. We'll replace him though with du. All right, perfect. From this stage, we can just go ahead and simplify. So first thing would be to multiply this on in. So u times that, u squared times u squared will give me u to the 4 du. All right, and from here we can just go ahead and take the simple antiderivative since it's in its simplest form. Final stages, I'm going to go u squared. Taking the antiderivative, we're going to be adding 1, which will make u cubed. The opposite of the cubed is 1/3, so we're dividing off by 3, minus, drop the sign right down, 4 plus 1 becomes 5, so we have u of 5 all over 5, or 1/5 if you'd like to see it. All right, we are not quite done because we do have to undo our substitution for the final answer. So our u sub, if we remembered, was sine. So go ahead and plug in sine everywhere you see u. we have sine cubed x all over 3 minus sine to the 5th x all over 5. And then that is our final answer for that problem. All right, let's go ahead and do another problem. This time we'll do the integral of t cosine 5, and we're going to have a t squared dt. All right, the first thing I notice on this kind of a problem is this is not normal looking. We are used to seeing cosine of x, cosine of t, but not t squared. So because of that, I'm going to go ahead and do a u substitution. Another way to know that you can do a u substitution is if you ever have a function within another function. In this case, we have t squared inside of cosine. Function within a function. Go ahead and do a u sub and take him on out. So t squared will give me 2t dt. All right, I do not have a 2 anywhere in this problem. I do have a t dt right there and right there. So right here and right here is this portion, but I need to take out that 2. So I'm going to divide it off. So I'm going to have 1/2 du equals t dt. In this case, we can just go ahead and pull that 1/2 right on out front. So I'm going to have 1/2 the integral. Go ahead and plug in your u substitution. T goes away. He's part of our du as well as dt. Cosine, we don't have anything for the cosine. So the cosine in this case is going to stay. Cosine 5. And then our t squared became u du. Perfect. All right, now this is something that we can actually work with. Because the power on this is odd, we're just going to go ahead and split that. So keep your 1/2 out front. Keep your integral. We're going to go ahead and split this between a 4, so cosine 4u times cosine u du. All right, from here we can just go ahead and use any identity that we know, and in this case, because cosine is what we split, its opposite is what we're going to use. So 1/2, I split my cosine, now I have an even number I can work with. That is the same thing as using its opposite, 1 minus sine squared u squared. Squared to squared makes my 4. Don't forget our remaining cosine and du. All right, we are almost done. We do have one more substitution in this problem, so we'll go ahead and do that. I don't like to use u twice because we already have u and it can get a little confusing. So let's go ahead and use a different one. We'll say m and then dm. All right, in this case, I'm going to use sine again. Sine of u will give me a cosine of u du, taking the derivative. Let's go back to our problem. Do I have a cosine u du? Well, I do actually. It's right here. So we're good there with just substituting dm. And I don't see any other conflicting properties here, so we'll go ahead and rewrite this as the 1/2. We'll go ahead and plug in our u, so I have sine for u squared, cosine becomes dm. Excuse me, this is now an m, dm. See those u's and m's? That's why I never use the same letter when I do it. I still mess up. Okay, moving forward. 1/2. So 1/2, keep your antiderivative. Let's go ahead and multiply this out. If you need to write it longhand, go right for it. I'm just going to write it straight out. So we have a 1 minus, that'd be a 2m squared plus an m to the 4th. That's a 4 dm. All right, perfect. Now we can just simplify straight out. So this will become 1/2 times 1, taking the antiderivative of 1, will give me m minus negative 2m. We're going to go ahead and add 1 to the power here. Becomes 3. So we have a negative 2m cubed divided by the 1/3, opposite of the 3. There's that one. And we're going to go add. 4 plus 1 will become m to the 5th divided by 5. All right, perfect. So now let's just undo the substitution that we have done. And we have 2 of them to undo. Whenever you do a substitution, make sure you undo your substitution. This was substitution number 2 and number 1. So let's go ahead and take a step back. We have 1/2 multiplied by m, which is sine u, but let's do it all in one step. Sine u will become sine t squared, which was our u, minus 2m, which is sine again, and this is cubed, and what's inside our u? T squared again. This is all over 3, plus m again, sine, to the 5th power of u, which is t squared, all over 5, plus c. All right, so that's going to be our final answer for that one. I hope this helps. I will make sure to put out more examples shortly.